Okay, this is part 2 of lesson 2 for unit 10 for statistics students. It's going to be a race against time to see if I can finish this one before my battery runs out. So if it abruptly stops, that will be the reason why, but hopefully it won't take that long. We're going to go through the 4-step process for this 2-sample t-test for the difference in population means. And the problem is talking about increasing the amount of calcium in our diet and the possible reduction of blood pressure. So examination of a large sample of people revealed a relationship between calcium intake and blood pressure. So this is like, there's an observational study, they noticed this, so because it doesn't imply causation, they decided to make a randomized comparative experiment. So the subjects in the study were 21 healthy men. They volunteered to take part in the experiment. They were randomly assigned to 2 groups. 10 of the men received calcium supplement for 12 weeks. The control group of 11 men received a placebo pill that looked identical. The experiment was a double blind, which means the people interacting with the men also didn't know what the men were given, but the researchers had some secret list where they knew what was given. The response variable is the decrease in systolic blood pressure for a subject after 12 weeks in millimeters of mercury. An increase appears as a negative number, and this is the data. So this is the decrease. So this guy decreased 7 millimeters, where this guy decreased -4, which means they increased 4 millimeters. So we have the calcium group and the placebo group, and we just want to know, do we have convincing evidence that a calcium supplement reduces blood pressure more than a placebo on average for subjects like these 21 men? So I'm going to start out by stating my hypotheses. So my null hypothesis is, I don't think there's a difference. The population average decrease for the first group, and actually I'm not going to use a 1, I'm going to use for the calcium group, minus the population decrease for the placebo group is the number 0. There is no difference. So the alternative is that, what am I trying to find? That the calcium reduces it more than the placebo. When you're trying to figure out the order for this one, I would think the average of the calcium is going to be more than the average of the placebo. And if you rearrange it to our format by subtracting mu sub p, I would have that the difference in these population means is a number greater than 0 after I've subtracted this from both sides. So I have to have my hypotheses, so I'm just going to use mu sub c as the population average decrease in systolic blood pressure for healthy men like the ones in the study. That's important to say. This is not for all the population. This is just for the ones like the guys in the study who took a calcium supplement. And mu sub p is the exact same thing, but for those who took the placebo in the study. My plan is to run a 2-sample t-test for this difference in averages. So that's what I'm going to put first. I have to state what I'm using. That's not how you spell sample. And the conditions I have to test, I have to make sure I pass the random condition. You'll notice I'm not putting independent here because this is an experiment. I don't have to worry about my 2 groups being selected independently because I have 21 guys to start with. There was some random process that assigned them to the 2 different treatments. So I'm just noting that. The 21 subjects were randomly assigned to either calcium or placebo treatment. I don't need to check the 10% condition because these guys weren't drawn out of the population, so I'm just skipping that. And the normal/large sample, those are not large samples. 10 and 11 are not more than 30. I don't know the shape of the population distribution, so instead I sketched the data. So I took the sample data that was given to me and I put them on dot plots. By looking at them, again, I'm looking to see if it's plausible these came from a normal distribution. So even though the sample sizes are small, the dot plots show no strong skewness, and also no outliers. So we don't know for sure, but it's plausible that my data came from a normally distributed population. So now I can actually go through and get to my do step. So we're going to actually go through these calculations. So I put the data into my calculator and ran my 1 variable statistics off of it. And I found that my sample mean for the calcium group, so x bar sub c, is 5.000, so almost 5. And the standard deviation for this group was 8.743. Sample size for this group again was stated to be the 10 men. Sample data for the placebo group, I got negative 0.273. Standard deviation of 5.901. And the sample size for the placebo group was 11 men. So we can use this to calculate our test statistic, but remember you could also just jump to your calculator. So because that way tends to be less error prone, that's the way I'm gonna have you do it. So I'm gonna run through that here. So in my calculator, hopefully you can see that, I would like to get to my tests, and I'm running a 2-sample t-test. I have my stats in here, so that would be 5.0000, 8.743, and 10, negative 0.273. And this time we are not running a two-tailed test. This one is a right-tailed test, so I'm going to have that selected because we're looking to see if it's greater than this, if there is the difference for one group is more than the difference for the other. We always select no for pooled, and when I calculate it, it's spitting out the standardized test statistic, which we could have done by hand. It's spitting out the degree of freedom using with that formula that this is the more accurate way to do this, or more precise, I guess I should say. And then the p-value calculated using this degree of freedom, and technically TCDF if I wanted to show that work. So that's what I'm going to note. I'm just going to state using technology because that's all I did. We got a standardized test statistic, p-value, so because of this, we don't have a very unusual difference. So if there is a difference, it's something that is look at my order. Yeah, if I subtract this minus this, I'm going to get a positive number. There is some evidence, where is it, that my difference is a positive number. But if I look at how unusual or how far from the center of this distribution it is, we're quantifying it with this. And while that's not a super high probability, that p-value is greater than the line we set of our level of significance. So I'm going to say because our p-value of 0.0644 is greater than alpha 0.05, we're going to fail to reject the null hypothesis. Assuming the null hypothesis is true, assuming that the difference is just 0, this should happen to us about 6% of the time just by random chance. So because of that, we don't have evidence in favor of our alternative hypothesis. So that's what I'm going to note next. We're going to kind of say what this means in terms of our alternative. So it does not provide convincing evidence that the true average decrease in systolic blood pressure is higher for men like these who take calcium than for men like these who take placebo. So we didn't have evidence that the alternative would be true. The last thing we're supposed to do on this problem, where is it, is interpret the p-value. What does a p-value mean for this particular problem? The p-value is always built on the assumption that the null hypothesis is true, and what's the probability that you'd get the sample data that you got, or something more extreme. So that's what I'm noting here. Assuming that the null hypothesis is true, which we said was mu sub c minus mu sub p equals 0. Assuming that is true, then we have that p-value 0.0644 as a probability of getting the difference that we got of this or something even larger just by random chance in the assignment of these two groups. So it happens, and because it's not statistically unusual enough when it happens, then we're just thinking that we have to stick with our null hypothesis. There's another example on here that I don't have done, and it is going to be a do-it-yourself. I would highly recommend you work on that on your own and then check the answer key to make sure that you're doing it right. But the next thing we're going to talk about, I'm going to